All right, good afternoon. I hope you had a good lunch. The next half an hour I will talk about GitHub Action security. What are typical problems? How can your repository maybe get hacked? And how to simply avoid that. Just wondering, who's using GitHub? Anyone? Yeah, a few? Who's using GitHub Actions? Also a few, good. Good, let's get started. So here we have a simple GitHub repository. And in this GitHub repository, we have some automations on the issues. So here we go to make an issue. And very simple issue. And there will be some automation running in the background once the issue is created to process it. So we see here the issue is currently already processed. And in a few seconds, hopefully, we get some feedback. Good. So we see the issues automatically processed. Now, that's nice. That means some data is taken from the issue context. So let's see if we can attack this. So what we try to do is here to do an injection, like an SQL injection, but then with a script injection in my GitHub Actions. And so here I try to inject with a script inside GitHub Actions. And you will see in a few seconds I show the script quickly, but the script is not so important. Most important is here what the impact will be. So now we see we have stolen the secret from this repository. We have write access to the repository. And we even can write files, what we will see here. So we have created 2 files. So with very simple mistakes, you can end up in a situation like this. So your trusted secrets get exposed. Someone can write information in your repository, and from that moment, everything can go wrong. So during the talk, I will explain a couple of patterns like this and how we can easily mitigate them. My name is Niek. I work as principal engineer for Philips, currently in the security team of Philips. Good, GitHub Actions. So GitHub Actions is, let's say, nowadays the most used ecosystem for CI/CD, certainly for open source, and also inside enterprises becoming one of the biggest systems for CI/CD. GitHub Actions is, in general, not a classic CI/CD system. It just acts on any event happening in GitHub, in the GitHub ecosystem. So you can run a workflow based on an issue, on a manual trigger, on maybe a time-based trigger, or, of course, changes in your code like push or pull request. So that is all defined in a workflow file. So we code the build in a workflow file, in a YAML file. And once that gets triggered, in your workflow, you define jobs, and jobs are divided in steps, and the steps are the pieces that are executed. Every job gets executed on a runner. That is the compute piece that is executing, let's say, the workflow. And the job is then the isolation level. So each job gets its own runner assigned to get executed. So this is in a very, very short, let's say, a brief description of how GitHub Actions works in general. So a workflow in GitHub Actions looks like this. So this is a very basic workflow. I think for now it's not so important that we exactly understand what it is doing, but let's go over a couple of steps. So the first step is we define what type of events trigger this workflow. So that in this case it is a push and a pull request, so that our code changes. Next we define which type of runner I want to use. So in this case I use a standard GitHub hosted runner, Ubuntu latest. Then I use what's called a GitHub action. That's a reusable piece of code that I just define in my workflow. And that piece of code is then doing something. In this case, it is checking out, cloning the GitHub repository in context of the workflow job. And then next, I run some scripts. In this case, npm, but of course, that could be any script that is doing the job for you. So if you do Java, it's maybe Gradle, whatever. Good. So that is the workflow. As I showed you in the workflow, you saw the GitHub action. So the checkout action we see here. The GitHub action is the Lego brick. So that's the component that we can plug in our workflow. Those are distributed via GitHub repositories. So they can be inside your enterprise or company. So they could be some level of private, or they could be public and open source. So it is an external piece of code that you run in your trusted context that either comes from your company or public from open source. So I think it's already clear that here is maybe some type of risk. And runtimes, actions runs in either Node.js, Docker, or Shell. So that is, for today, not so important. And what is important, the action runs in context of your job. So in some way of extent, that action is running code, and that code that defined is in that action has access to the context of your job. So if that code is completely malicious, it can also steal things from your job. Good. I think this already gives an idea why GitHub Actions is a good target for attackers. So first of all, it's the major system for open source. So that means that most of the open source projects are using this as a build system to build and release software. So gaining access to those systems allows you potentially to publish malicious packets or steal maybe secrets. And with the secrets you can do then what the secret can do. At the moment you use GitHub Actions, for example, inside in your company, it could also be a way to steal your company code, of course, because the action has access to your source code. So these are all reasons why GitHub Actions is an interesting attack vector. So let's have a look again on the workflow. So here we see a very simple workflow. And yeah, this workflow has some dangerous things. Anyone, any idea? Good. What we see here is that this workflow here, we see version 45 is used. And that's only a major version, which means any minor patch version gets automatically used here. So every time you run this workflow, you get most likely the latest code. And if this open source action that we see here, the TG action, get malicious, then we automatically get the malicious code inside our workflow running. So we maybe could think we can fix that simple in this way by just pinning the version to an exact version. However, we have to remember that GitHub Actions are distributed via GitHub repositories. So we're looking here to a Git tag, and a Git tag is mutable. So the tag that we see here is potentially mutable. So however this looks like safe, if an attacker or someone changed the tag and let's point this 4507 to some other place in the repository, you're still under attack. And that's exactly what happens earlier this year with the attack on TG Actions. And here, malicious actors were able to compromise tokens from the owner of the repository. They inject malicious code in the repository. They rewrite all the tags. So all the tags from all the releases just point to the malicious version. And everyone using TG Action was under attack. And the result was that this action starts printing out secrets in your repository in your workflow file. Boom. This problem is easy to solve. So we can solve this by not using the Git tag, but you see in every simple example, and if you use AI, it also generates, of course, the version thing for you. But if you use the SHA log, we are 100% sure that we always look to exactly the version that we want to use. So in this case, our actions are immutable. And in this way, we are safe as long this immutable version is safe, of course, but that we assume for this moment. So by applying this pattern, by default, to all the actions you use, you are much safer to those type of supply chain attacks. And with Dependable, you can also easily update the SHA versions, so you don't have all the manual effort to find out that difficult string and then put a nice command which version it is. That can be done all automatically with Dependable. So we have a next example. This example is maybe not so complicated, because if you remember the short video I was showing in the beginning, that was the script injection. That's what we see here. So in this example, the user input goes directly in the shell. And when we do that, we can do things like this. And here, an attacker is then able to, for example, create a reverse shell. And if you're able to create a reverse shell, you can enter the compute environment and maybe your full infrastructure for your runners get compromised. Assume that you run maybe your self-hosted runners. So this is a risk when you have those kind of things. So what we have here is, and the result could be, if you have script injection, that an attacker could start secrets, it can inject malicious script in your runtime environment, it can start watching everything happening in the memory, your full infrastructure can be compromised, maybe it can access all systems in the same infrastructure, so it's dangerous. Also, this is very simple to avoid. So what we do here is not directly inject the user input in the scripts, but they go via an environment variable. And that way we are sure that the input from the user is sanitized and safe to use. Good. One more example. In this example, it's a bit more complicated, I think. And I combined a couple of other things that we already saw together. But the problem here is that, first of all, we use a pull request target. And the pull request target allows someone that has no access to your repository, with a fork, make a pull request to your repository, that job gets running inside the context of your repository. Which means that potentially this job gets access to secrets or anything in your repository. And by clone, well, we do that very on the bottom even, and that's, I think most people not even realize that, but we just run a script that shows the branch name of the branch from the fork. And even with the branch name, you can do injection, because the branch name is also a user-controlled input. So this is also possible to misuse for injection. The pull request target was the cause of the Singularity attack that we had end of August. And with this attack, attackers stole repository tokens from the NX package via pull request target that was still in the repository available. That leads that from thousands of developers, secrets were stolen, and then you have really to think about Amazon access keys, GitHub tokens, other cloud tokens from companies. They were stolen and published in a public repository from the user, because the script was then using the GitHub token that was available on the developer machines and start publishing that on GitHub as a public repository. And in the next cycle of the attack, it even starts making private repositories from those persons public. And there was, I think, even a company that in this way exposed 500 private repositories public. All caused by a very simple mistake. So, pull request target, I would say in most cases it's better to avoid, and if you use it, you should be really sure what you're doing and ensure that no harm can be done when you use this construct. Sorry. Good. So I've shown a couple of things on the workflow. What is maybe risky ways to use it? Another thing that we have to know when we use GitHub Actions, that is GitHub is injecting a short-lived token inside your workflow. So at the moment your workflow gets executed, a token is injected with the name, environment variable name GitHub token, and that token is short-lived. That's good, because the token is only valid during the lifespan of your workflow job. But the token that gets default injected has quite some broad permission. And if you just take all the defaults, the token has also write permission to your repository. So with this token, you can write files. And so you see here, I can even push git tags, for example. So what you can do is define the permission for the token. So what we do here is define explicit the permission that I want that the token has that get injected. So with a minimal privilege access in mind, I start my workflow with defining no permissions at all. And then next, on the job level, I say, okay, the only thing this token needs is read access. Result is that this git push will fail, of course, because there is no access to write. So another thing about secrets is that in many cases we still have to use secrets that are long-lived, and they are always a problem. In many cases, you will have requirements that require you to rotate those secrets. And so how do you ensure that you rotate the secret in time? And if you have many secrets, how do you rotate them all? Is this mine? I think so. Yeah, good. So that's difficult. And if you have those secrets, if something goes wrong, the blast radius is also high, because assume that the secret gets stolen. Then the time between that you know that it was stolen and start revoking the secret, that whole time window, the secret is valid and can be misused. So if you have short-lived secrets that only valid during, let's say, the execution of the workflow, you don't have that problem. It's still a short risk, but a very short time window. So in this example, we see, for example, for Amazon, how we use such kind of secrets. But when you use cloud, you should be aware that those secrets are not needed. So if you use cloud, you could always use something that's called OIDC, which gives you a way to generate a short-lived secret for your cloud environment. In this case, I show here for Amazon, but it can also be the other major clouds. Even Artifactory supports this, to inject a short-lived token in your workflow. But when you start using this, let's say, zero trust principles, it becomes very important that the trust condition that you see on the bottom, you define very strict. Because if you say in the trust condition at the subject line, repository repo semicolon star, then you allow everyone on GitHub to get access to your cloud account. I'm quite sure that that is what you don't want. So when we use secrets, it's important that we keep them safe. So also for our secrets, we can define boundaries. And a way to define boundaries in GitHub Actions is defining environments. So you can, for example, only allow a certain secret to be available in a production environment. And then you can set constraints to the environment that the environment can only execute on protected branches or after some explicit approval. And that safeguards you that on any branch where development is happening, someone can also access the secret. And when it comes to OIDC, so the trust relation is very important. So I show you here, and this is examples that are real. So those people think, oh, it's handy, my project.star, because my team has this name in my company, so I do my team star, and then it works. But that means everyone in your company that can create a repository with that name can access your cloud account. And maybe in a small company, you're fine with that. But in a company where 10,000 people are working, maybe that's not a good idea. So also better to avoid this. So what I've shown so far is a couple of patterns. So when we use third-party actions, lock them by the SHA, not simply by inversion, and maintain them then with dependable automatically, so you don't have a burden on updating them. Be very cautious with dangerous triggers, like pull request target. Keep an eye on script injection when you start processing user input, like you should also do in every software program you write. And you get the tokens, define permission blocks, use minimal privileged access. So far I have shown quite some patterns and all kinds of things that go wrong and really went wrong last half year. So let's see how we can easily do this better, how you can even start today or tomorrow doing this simply better. So first of all, in GitHub we can define configurations on our organization or our repository to restrict how we use GitHub Actions. So we can define with allow list what actions we allow to use. We can force locking by SHA. So then we force that only actions that are truly locked by SHA get executed. And that means also transitive. So if you have anything that transitive is not locked, it fails. And we can minimize the permission of the token that gets injected. So then by default, we can inject a read-only token and not a read and write token. We can still use a write token in the workflow, but we have explicit request and write token. So That is the configuration part, but the better part is if we also can avoid the patterns in our code. And for that, we can use GitHub Advanced Security, which is free for open source repositories. For private repositories, it's the license model. And with GitHub Advanced Security, you can enable code QL scanning for GitHub Actions. And that will warn you and block most of the patterns I have shown so far. So GitHub Action is a good alternative to protect yourself better. Then we have a couple of open source tools, and I have listed here 3 of them. We have Sysmore. And Sysmore is the tool that was already out there before GitHub Actions, GitHub Advanced Security even starts supporting this. Sysmore is really an advanced tool, and I think the most advanced tool to protect your security for your GitHub Actions. And it is, I would still stay ahead of GitHub Advanced Security. The tool is also very highly configurable, much more than GitHub Advanced Security, and of course you can run it in your CLI. You can connect it with a pre-commit hook, so you can really avoid early in the chain, shift left, that you get those problems. Then we have Checkov. It's a tool that typically is used in IAC, infrastructure code. That tool is doing some level of checks. So I think from the top of my head, it is checking for those permission blocks, but it certainly won't find problems around locking your dependencies immutable. So it gives, I would say, very basic level. I also saw that some people thought ActionLint is doing something. It is doing something for sure, but not on the security side. So it helps you to write better workflows, but that's it. So these are 3 nice open source tools that you can easily plug in your repository. So for Sysmore, it would like a bit like this, and I will show it in a minute also in the GitHub repository. So when we have Sysmore here, I run it in the CLI, and then it starts complaining, what is the problem? I get really blocked on my local. I can connect it to a pre-commit hook, and so I can avoid security risks. So what I have here is a simple repository that is using Sysmore. So in this repository, I have here, let's hope the network is doing it. I have here a workflow, very simple workflow, and this ensures that everything that changes in my workflows gets checked by Sysmore. And the tool is also configurable, and this is a very minimal configuration, but you can also say, okay, if you say some rule I don't like, so you can start ignoring it. So there's a configuration file, so that is Sysmore. And when we look on this repository, I think we have here a pull request. This one. Yes. So this is a PR where I add a file to the repository. I add a workflow file with some actions. So I have also added dependency review, which is using Open Scorecard, which was mentioned, I think, in the first talk as well, to see what are the dependencies and are they some kind trustworthy. And then Sysmore is starting complaining on many things that are not done very wide in my workflow. And also explains, of course, how to fix them. When you do this with GitHub Advanced Security, you get a similar approach. What is nice maybe with GitHub Advanced Security, and you're also using Copilot, then you get also automatically suggestions from Copilot how to fix it. Not sure how good they are. That's something you have to judge yourself. But this tool is helping you, and now my workflow with all kinds of dangerous patterns is blocked. So I don't get in my repository. And that's really the good thing. Good. So I covered today a lot of patterns on things that can go wrong in your workflow, how you simply can avoid them, and how you can use tools like GitHub Advanced Security and Zismore to protect that. I have not covered those topics. So first of all, our third-party actions that we use, you should think about what you can trust. Because it is a piece of code, like any open source component that you download, you run in your trusted environment. So you have to ensure that you can trust that component running in that environment. Huh? Do you like to download just random stuff from the internet and execute it on your laptop? Do you feel very confident that always with it? That's also what you do here. Huh? So you have to ensure that what you do, that you can trust. Then we have the GitHub runners. If you use the GitHub hosted runners, they are ephemeral. If you run your own self-hosted runners, then you also have to think about how do you secure them, because they are also in some way an attack vector. And especially if they are non-ephemeral, then at the moment an attacker has access and keeps that silent access, you have no clue what can go wrong. So that is the self-hosted running part. So I think GitHub Actions is still an awesome system to automate literally almost everything related code. But there are some small dangerous patterns. And typical, your workflows are very powerful. They make your releases, they deploy to your cloud systems. So they are very powerful. And it's a good practice to secure them. If you are in your company or on your open source project. For both cases, it's simple to secure them, and it's incredibly important. And with tools like GitHub Advanced Security and Zismore, this becomes very, very easy. Good. In this repository, you will find some links to the slides, some articles that I also use for this talk. You find also 2 demo repositories, one for Zismore that I showed quickly, and another one for GitHub Advanced Security. So you can check this out after this QR code. And with that, I think we have a few minutes if there are some questions. Do we have questions? Silent. No questions? I think there's a question, yeah, in the back. Do we have a mic?
I do not have the microphone.
I think maybe it's not needed.
No, it is needed. It needs to be recorded and heard.
Recording, yes,
yes.
Of course.
While we wait, oh yes, go ahead.
Hey, thank you for the talk. I have a question. What's like the best practices to apply this approach at scale? Like we have big organization on GitHub with many repositories. What's the best approach to protect our GitHub actions?
You want to protect the GitHub actions that the actions you make yourself, or the workflows?
Workflows and our own actions. Like you've shown our one static or 3 static scanners. 2 of them are security related. Should we add these actions to all these projects, or is there something like we can apply it at scale?
Indeed. So that depends on how you manage your organization and your GitHub repositories, which is for every company, I think, differently. But on organizational level, you can force a couple of things. So I've shown, for example, where it is? Yeah. So on the configuration side, and there are a few more configurations, this is what you can do on repository level, on organizational level, and an enterprise level. So you can enforce this for everyone in your organization or even in your enterprise. But if you start doing that tomorrow and you click on only allow SHA-protected actions, and no one is doing that, everything fails directly. So that is the problem if you start enabling this. Same with read and write access. If people using not defining, clearing the permissions, and you swap from read access to from write to read only, then everyone is using the standard, get also potentially failing builds. So this is what you can do on configuration side, and adding GitHub Advanced Security or Zismore. What you can do is have required workflows in GitHub, and those required workflows you can force. And you can do that for everything, or you can do that based on repository properties. So you could also say we define repository properties. That's metadata on your repository. And then you can say, okay, for, let's say, everything that deploys to Amazon, we want to enforce this workflow. So that's a way how you can balance those kind of things with those checks. And you can enforce things. On how to structurally check if the actions that you use from the public internet, that you can trust that code, I have no good answer. If someone knows that, I would really like to know that, but I've not seen a very good approach. So, yeah.
Okay, thank you.
Anyone else? I can't see you, so you need to...
I thought in the back was one more. There is a question.
Wait, you say there, but I...
Yeah, in the...
Please wave again.
Yeah.
I see you.
Yeah.
No, I don't see you anymore, but I saw you.
Yeah, yeah. The mic is already traveling.
You can hear me, right? We're using like repository dispatching, like Peter Evans' repository dispatch, and in order to use that, you need to give one repository access to another repository. And in order to do that, you need to create a fine-grained token, which lasts a lot, and it's a very, like, to me, it seems it's not really secure. So is there a way to amend that?
Yeah, so you can create a fine-grained token. If you only use that token on that place, it's maybe okay, but you create a static secret, and then most likely you have requirements to rotate them, and the more you use, the more you have to rotate, and the more complex it becomes. Other alternative is that you use a GitHub app to do that, but then you have another problem because then you have an SSH key that you need to rotate. So the big problem is here that GitHub has no real good answer on this. So I think what you use is one of the good ways to do. So either a GitHub app or a fine-grained token, and hopefully not have a user that that can leave your company, because then everything also starts failing. That are the only solutions you have. And push on GitHub for something better, because
yeah, it's not great because I still keep it on my laptop somewhere in case I need it. I just have an access token.
Yeah, good point. But this is also a problem when you use in your workflow, for example, other internal repositories, and then you have the same problem because you cannot access them. Good. We have 1 minute, otherwise it's also great. We have one more question, maybe?
Actually, I may have to cut in.
Oh, okay.
I may have to cut in because we're up for a break. You have 10 minutes, and you see that red shirt? For once, he's easy to spot. So if you have extra questions, do not hesitate to go up to him. Thank you very much.